What I'd like to do now is use what you already know about splines and regression trees to connect with linear regression and help us transition toward that topic. But one of the reasons I like to connect these topics in the way that I'm about to is so that you don't compartmentalize them in your mind. So I don't want you to think, okay, sometimes somebody will tell me to do a spline, so I'll do a spline. Sometimes I'll be told to do a regression tree, so I'll do that. Sometimes I'll be told to do a linear regression, so I'll do that. Actually, as the person in charge of a data analysis, you're going to be choosing between the methods available to you. So it's important to know what their pros and cons are and how they work in various scenarios. So what I'm going to do is I'm going to go through several different scenarios and show you what each of these different methods will do. So here's our setup. We just have a kind of little toy example here. Suppose we have just one binary predictor. Let's call it X. This binary predictor is equal to either 0 or 1. Okay, and then we have some continuous outcome variable that we'll call Y. Okay, and we'll just kind of make up an axis. For our purposes here, we don't care too much what it is. And suppose, so if we have just this one binary predictor, suppose the data looks like this. So when X is equal to 0, we get some dots centered around 10. Suppose 10 is actually the mean of the Y's when X is equal to 0. And then suppose when X is equal to 1, the dots look more like this. So suppose that 20 is actually the mean when X is equal to 1. Okay, so that's our data. And what I'd like to do is I'd like to think about what the different models that we've already learned about and that we're about to learn about would do in this case. So for example, what is a spline going to do? Well, splines try to connect the dots. And let's see, how's it going to do that? Well, there's only two different X values. So what's a spline going to do? It's going to take our mean value when X is equal to 0 and connect the dots with that value when X is equal to 1, right? That's it. Okay, now we actually didn't learn a lot here. We don't really care about what happens when X is between 0 and 1 because we just decided that X is a binary variable. X is only equal to 0, 1, right? It's something like, did you go to college or not? Or is this course remote or not? So X equal to 0.5 is not meaningful. But the point is that the spline predictions are just going to be the means. So again, if you use a spline and then you say, okay, X is equal to 0, what's my prediction of Y? It's going to be 10. If you use a spline and you say, okay, X is equal to 1, what's my prediction of Y? You're going to get 20. So the spline is just going to give you back the means. What is a tree going to do? Let's make a tree. I'll make the tree green because trees are green. Okay, so see if you can answer this question yourself. What are the two branches going to be in the first split in this tree? Well, there's only one predictor, so we're going to have to split on that predictor. So we'll go to the left, say if X is equal to 0, and to the right if X is equal to 1. Okay, and if X is equal to 0, what should our tree predict? Well, when X was equal to 0, the mean of the Y's was 10, right there. So when X is equal to 0, prediction of Y is going to be 10. That's our best knowledge of what will happen. When X is equal to 1, what's our best guess? Well, here it was 20, right? That's it. This is a model for the mean. In other words, it's a model that helps us predict the mean of Y given a predictor, in this case, just one predictor X. So note that in this case, the spline and the tree actually give us the same predictions, right? They both just give us back the observed mean of Y when X is equal to 0 or 1 for the situation with just one binary predictor. So they give the same answer, the same prediction. Now we're going to introduce another model, which I'm guessing is one you've heard of. Depending on the courses you've had before, you might have worked with it a lot. You might have worked with it very little. Doesn't matter here. Okay, you're going to learn about it right now. So linear regression. And here's how I want you to think about linear regression, at least for right now, but actually all the time. This is what linear regression is. Think of linear regression as an attempt to write down an equation to summarize the relationship between X and the mean of Y. Okay, that's how I want you to think of linear regression. So here's how we're usually going to write it. We're going to write an equation. So we'll say the mean, I'll put this kind of in a box over here. The mean of Y given X, so that vertical line means given. So if you tell me X, what's my best guess at the mean of Y? Given X, what is the mean of Y going to be? Now, with the tree, I answer this with a picture, right? This tree picture. With a spline, I used it by trying to draw, connect the dots right onto the scatter plot. With a linear regression, what I'm going to try to do is write down an equation. Okay, I'm going to try to write down an equation. So how am I going to do that here? Well, look, I actually think the predictions from the tree and the spline are the best I'm going to do, right? Like, you're forgetting what fancy name I'm putting on any of these models. Given this data set, if you tell me that X is equal to 0, my best guess at the mean of Y is 10. If you tell me that X is equal to 1, my best guess at the mean of Y is 20. That's just what this data set says. So I want to write down some kind of equation such that when you plug in X, you get back a 10 if X is equal to 0, and you get back a 20 if X is equal to 1. Okay, I'm not going to make you stop here and do it. But I want you to be thinking about it ahead of me. Okay, so when X is equal to 0, I hope that I get a 10. And when X is equal to 1, well, then I want to get a 20. So I want to get 10 more than I have here. Okay. And I claim that that equation works. So let's just check. All right, if X equals to 0, right? Well, you could plug in a 0 here. So you get 10 plus 0. Yeah, when X is equal to 0, this gives back 10. Oh, good, right? That's what we wanted, right? That's my regression prediction. When X is equal to 1, okay, let me plug in a 1 over here, right? So I've got 10 plus 10 times 1, I've got 20. Hey, it worked, right? I got a 20 when X is equal to 1, okay? So you can draw a line if it helps you. That's the line 10 plus 10 times X. So yes, it is a line that has intercept 10 and also slope 10 in this case. Okay, but I'm more interested in the fact that when I plug in the values of X, I get the desired mean of Y than I am about labeling these values intercept and slope. Okay, so that's the point. This is the simplest example, but that's where how we're going to be thinking about regression. When we plug in the different values of our predictors, do we get the mean of Y that makes sense given the data? And how can we write down an equation that allows us to connect those predictors to the mean of Y that I think best summarizes what's going on in the data? But because we are learning about linear regression, let me just also say right now, if you haven't seen it before, that the intercept is usually called beta naught. It's not a B, it's a Greek letter beta. And the slope is usually called beta 1. Okay, so here I've got beta 0 is equal to 10, and also beta 1 is equal to 10. Okay, so we did one binary predictor. Now let's do something very slightly more complicated. Let's say we have one categorical variable. Let's call it a predictor. One categorical predictor. So instead of just saying that X is equal to either 0 or 1, now X is equal to one of three things. It's equal to either A, B, or C. But now it's something more like, are you a first year, a sophomore, or a junior, right? Something, everybody has to be in one of those categories. And let's still make a scale here. So this Y variable could be equal to 10 or 20 or 30, right? So just to give ourselves a little example, suppose it's something like Wellesley's doing a fundraising pitch and they're asking for money for something, and we want to know this graphic is supposed to show how much money is donated by people who are first year sophomores or juniors, something like that. Hopefully they're not asking you guys for money, but suppose that they were, or more money than they usually do. So let's go through the same process. Now, let's just point out that a spline doesn't make a lot of sense. So I'm just going to write that. I'm going to write spline, nope. Right, spline doesn't make a ton of sense. We don't have a variable to connect. So if we did use a spline, it would just give you back the mean. Let me actually draw in the data. So suppose that when the predictor was equal to A, on average, we got a 10. And when the predictor is equal to B, maybe on average, we get a 20. And when the predictor is equal to C, maybe it's in between. Maybe you get a 15. Okay, so if you did use a spline, you just get back those means, but I don't want to talk more about the spline in this case, because again, the spline makes more sense if you have a continuous variable. Let's talk about the tree though. Okay, the tree maybe could make some sense. So if I tell you that we have A, B, or C, well, the rule about trees, at least the conventional sort of trees, that you have to have binary splits. Trees have to split just 2 at a time. But I have 3 groups. I want to eventually split into 3. So how do I do that? Well, you could write your own new kind of regression tree that makes splits at 3, right? You can do that. But the conventional way to do it is to split once and then to split again. So for example, when you make a tree that to describe the data here or to make predictions from the data here, one possible split would be, okay, well, it's either A or B or C. Okay, that's one way to split up all the people in this data set into 2 categories. Their predictor variable is equal to A, or else it's not equal to A. It's actually either B or C. If the predictor variable is equal to A, looking at the data set, well, my best guess at the mean of Y is 10, right? There it is. Okay. Okay, and if I am in the B or C group, well, I want to split again, right? Because I want to know specifically, are you in B or are you in C? And if you're in B, looking at the data, my best guess is 20, because that was the mean there. And looking at the data, my best guess here is 15 for C. Okay, so I'm going to kind of draw those predictions right onto the picture. Right. So in this case, the tree would give you back exactly the predictions that you'd think looking at the data set, but this is what the tree would look like. Now let's try to make a linear regression. Actually, let me go back for a second to the previous slide. I want to write one more thing on it. What I want to write is all 3 methods lead to the same predictions. Okay, I think that'll help give us context as we go back to here. Okay, so now I want to talk about linear regression. So what I want to do is I want to write down an equation that connects the mean of Y given these variables, given this predictor variable. So I want to be able to plug in A, B, or C, and then I want to get out a mean of Y. Now, here's the thing. That means that I have to be able to plug in a variable that's equal to a number, right? So if A means first year, that's not a number. I need to be able to plug in something that can go into an equation. So what I'm going to actually do is think about A, B, and C as separate indicator variables, or maybe you've heard them called dummy variables or binary variables. That's what I've been calling them. So A is either equal to 1 or 0, B is equal to either 1 or 0, and C is equal to either 1 or 0. So if you're a first year, then A is equal to 1, B is equal to 0, and C is equal to 0, for example. So as soon as I do that, then I can write it down this way. I can talk about the mean of Y given the A variable and the B variable. And I don't actually have to write down C. Let's think about why not. So again, imagine that A means first year, B means sophomore, C means junior. If I tell you whether A is 0 or 1, and I tell you whether B is 0 or 1, then I claim that you also know whether C is 0 or 1. In other words, if I tell you that you're a first year and you're not a sophomore, we would know now that you're not a junior either. If I tell you that you're not a first year and you're not a sophomore, then in this data set, you must be a junior. If you have to be one of 3 things and we tell you whether you're the first two in the first 2 groups, then we know for sure whether you're in the third. So we don't need to list all 3 variables here. But we're going to try to write down an equation, okay? So here's how we're going to do it. Well, when A and B are both equal to 0, that means you must be in the C group. And looking at this data set, my best bet at the Y value when you're in the C group is 15. Okay. But what if you're in the A group? Okay, so if you're in the A group, my best bet is going to be 10. So I want to be able to write down this equation so that when A is equal to 1, the mean of Y is equal to 10 instead of 15. So I'm going to write minus 5A, because now when A is equal to 0, I'll still get 15, which was the average in the C group. But when A is equal to 1, right, now it's going to be 15 minus 5, which is 10, which is what I want for the A group. Okay, now I want you to, in the question, write down the next term. What do I write over here it's going to be something about B. So this equation is complete and gives me back the desired prediction, regardless of whether I'm in A, B, or C.